Hello, kaya muli bwanji nonse. Tifuna ndikulandireninso ku phunziro lathu lero pamene tikupitiriza ndi phunziro la trigonometry. Lero tiyamba kupanga trigonometry 2 and imeneyi imaphunzitsidwa mu class ya form 4. Taganiza kuti tipitirize ndi imeneyi chifukwa tikufuna tizimaliziratu komanso audience athu ndi anyamata a form 3 komanso a form 4. So to make sure we cover for all of them, for all of their needs. Topic imene ikuyambira form 3 kumapitiriza form 4 tizimaliziratu topic yakuti zikhala zotithandiza. And today mu trigonometry 2 we are going to dwell much on the deriving sine rule, and in this lesson number 1 ndine Cicero Chuma. Introduction. Tikamakamba za trigonometry 1 imene imaphunzitsidwa mu form 3 inatithandizira kupanga manage kupeza ma missing angles, missing sides of a right angled triangle. Tikakamba za right angled triangle tukamba za triangle imene imakhala ndi 90 degrees. Yeah, so we are able to find the sides. We are able to find that angle using trigonometric ratios, and we applied SOHCAHTOA to help us do that, those trigonometric ratios. And all these were only possible but triangle, many the right angled triangle. Common in real life, you meet problems which are more than right angled triangles, which are in a form more than right angled triangles. You can have a scenario whereby there is no right angled triangle. So in such scenarios, you now need to have other means of doing that. So trigonometry 2, imenema consider form 4, will help you with such skills. Utandisira nokuti muthe kupeza ma missing angles, missing sides, without even having a right angled triangle. So it's all about triangles that are not right angled triangle. And one of the formula that you use to do that, it's what we call sine rule. Sine rule. So let us be together as we dwell back on this sine rule and do some examples and do some practical situations to see how do we apply sine rule in a right angled triangle for us to find missing sides, for us to find missing angles. An objective of this lesson today, lesson 1, basically to tipange derive sine rule. Kuti sine rule ndi chani inachokera pati. Yeah, so we need to do that. So we are going to show each other on how we derive that, and we are also going to know situations that you need to use this sine rule. Okay, we will show each other simple ways of how to know that here's where I have to apply sine rule. We are not going to use the normal method. I mean, we are encouraged more to memorize, but in this case I'll just show you how you use sine rule, how you use those other rules which are here, yeah, to solve your problem. So let's start by deriving sine rule. So for us to derive sine rule, we are going to use this figure here. It's triangle ABC. Triangle ABC is a triangle which is not a right angled triangle. Okay, but for the sake of this lesson, we are going to make it to bring in a sense of right angle. The whole idea of bringing in the sense of right angle is to borrow what we used in trigonometry 1 to help us build up on what we are going to use in this trigonometry 2, where we are going to play around with triangles that are not right angled triangles. So in this triangle ABC, in that triangle AX, we have introduced this point here, X, and we are going to make it to be perpendicular to BC. It has to be perpendicular to BC. By doing that, we have introduced the two right-angled triangles. Okay, two right-angled triangles. In this case, we have triangle ABX and the triangle AXC. Those are two right-angled triangles. But mukaphatikisa triangles awiri amene akupanga triangle imodzi, which is not right-angled triangles. So we can find this angle, find that angle by find that side by just using triangle ABX. And by just using triangle ABX. And if you look at the other triangle AXC, we can as well find side which is B and side which is X. Yeah, we can as well find this side, and that angle by using triangle AXC. So you will see that we have that side, we know that side, we know this side, we know that side, we can know that side, we can know that angle, you can know that angle, you can know that angle by using these two triangles. So we have this big triangle, which is not a right-angled triangle, but we have introduced that right-angled, that line, which has brought in two triangles, and those two triangles now are right-angled triangles. So we are using those two triangles to solve all these sides of that big triangle ABC. Those sides, we are using those two triangles to find those sides. We are using those two triangles to find those angles. So basically, that's that. So there are some labels in this one. Just a moment, let me just rub off. So in this one, we need to know now how to label these sides. Okay, how to label them. We have this point. We have this point B. Okay, this point B is going to represent angle. It's going to represent angle. This B1 kuru represents angle. Okay, so the opposite side of that B, you give it to be a small letter of B. The same applies to A, who will represent the whole of that angle, and the side of A, the opposite side of A, you are going to label it as small a. The same applies to that big C. The side opposite to that is going to be a small c. So the bigger letter is going to represent the angles, and the small letters are going to represent sides. Okay, and we are also now going to label this side here as H, which we are just going to let it to be H. Okay, so let's start and see how we can deal around with this. Sorry. Yeah, so let's say I'll use here we'll go to another side. So we're going to say in triangle, sorry, let me take this out. In triangle ABC, in triangle ABC, sign B. Okay, ABC. Let's use ABX, not ABC. Sorry. Let's consider this small triangle first. Let's consider this small triangle ABX. Okay. So let's consider ABX. Okay, ABX. So that triangle in this triangle, you can say that sine B, that is, we are going to use SOHCAHTOA, that is a right angle triangle. So we are going to use SOHCAHTOA to derive this sine rule. Okay, so this angle sine B, okay, will be equal to, so it's opposite over hypotenuse. So it's opposite over hypotenuse. In this case, opposite is h, and our hypotenuse is c. Okay, and we can find the value of h now. The value of h will be equal to c taken to that side will be c sine B. Okay, so after considering that, let us consider also triangle. We can say that's one. Now two. Say in triangle AXC, this triangle now. In that one, we need to find h. You can say as well, sine C will be equal to opposite, which is opposite is h. That's angle C, that is, over hypotenuse. In this case, hypotenuse is B. So, which means h will be equal to B sine C. Okay, I hope we are together there. We are together there. So, from that discussion, from that, we know that we have that equation and we have that equation. H in this side we have found that it's C sine B. H on that side we have found that is B sine C. So in this scenario we can say that each is ofanana, so we can equate them. Okay, therefore we can say that C, this should be small c, sorry, it should be small c. C sine B should be equal to B sine C. Okay. So C sine B should be equal to B sine C. In this scenario, we have taken away H. H is no longer there, you can see, because H is equal to that H and that H, so we can as well equate this one and that one because they are equal. So by equating those two, we have seen that H is no longer there, which means we are now remaining with triangle ABC, which is not a right angled triangle. So from here, you can comfortably say that sine B over, you can take B down, and the sine C over C. Okay, so by doing this, if you know that angle B, this one, and you know that side, and you know this angle C, and you don't know that side, all right. So by following the same, by just following what we have done here, we have found now we have almost derived the whole sine rule. Okay, so you can see that here we have dealt with B and C. A should be the same stuff. So you can say that we can conclude that therefore Yeah, so I just copied to this side the drawing, and there we had shown that sine b over b is equal to sine sine c over c. So in this case, we dropped this line deliberately. We can drop it anywhere. We can drop a line from there to there, which is perpendicular. So if you do that, you will find out that you will consider A. All right. So if you consider A, you will find the same stuff. You find the same stuff. Then if you combine those things, you will still see that even sine A over small a is equal to all those things. In this case, all the sides can be found, all the angles can be found using this formula. So this is what we call sine rule. This is what we call sine rule. So for you to find find sides, of course we are going to demonstrate that using examples. For you to find sides, you know that you need to find those small letters. For you to find angles, you need to find those big letters. Okay. Yeah, so let's proceed. Let's have an example. You see that is not a right angled triangle. And in this triangle, we have been given two angles, which is 36 and 52, and one side. Now the question is, how can we know that in this one we have to use sine rule? Remember, this is our sine rule. And if you are given an example like that one, you see they have just given you A, B, C. These are angles. Okay? It's good to find even angle h-tatu. So for you to find angle h-tatu, angle sum in a triangle 52 plus 36. Okay? Angle sum in a angle sum of a triangle. So if you do that on your calculator, if you do 52 plus 36, it's equal to 88, which means it's 180 minus 88. Then we find out that 180 minus 88 on your calculator will give you 92 degrees, which means this angle is 92 degrees. Okay, you just have to know that angle. All right, so in this triangle ABC, angle A, which is that one, angle A is that one, which is 52 degrees. Angle B is 36 degrees. And the side AB is 7.2 centimeters. If you have a angle C, okay, in this case, angle C is 92 degrees. Okay, now the question is calculate length AC. Calculate length AC. All right. Remember, how do you label those sides? On the opposite side, it will be, in this case, it will be this one is C. Opposite side of angle A is that one. Opposite side of angle B is that one. And our AC is B. Okay. So using our sine rule, okay. Remember, let's take our sine rule. Our sine rule states that if you say, in this case, we want to find sides. Okay, fine. Let's just do it as we know it. We know that sine, in this case, B over B should be equal to sine C over small c, which is that side, should as well be equal to sine A over small a. Okay, So having this scenario, without even guessing, without even memorizing, you need to understand in this one, what do I know? Okay, in this one, you know, what do we know from this one? This is what we know from this one. This we can take out. It's not necessary. We can take that out. Just trying to show that, not to find that. Okay, in this one, we know that C we know is equal to 7.2. Okay, B, which is, AC, B, we don't know. Okay, A, we don't know. And we know all the angles. So all the angles, we know them. We have no problem with that. So we look at C, we know. C is 7.2 centimeters. C we know. So on this part, we know Chapa Mwamba, sine, in this case, C, sine 92 degrees. We also know Chapansi, which is C, which is 7.2 centimeters. So on this one, the whole of this we are going to use. Okay, the whole of that we are going to use. And now, what do we want to find? We want to find AC, which is B. So let's go to where there is our B. Here there is no B. There's sin A over small a. So for us to find AC, which is B, we need to go where there is B. So we are going to use this part of the equation. We are going to use this part of the equation. That's how you determine whether I should use the sign or not. Had it been good, my conditions are they are not qualifying for us to use the sign rule. Whatever we have done here, this is gonna because this is an equation. You need to equate it to okay, for you to find the unknown. Yeah. So in this case, the whole of this part, we know it. We know the angle C, we know the side C. So we know it. So we can use this one. I hope we are together then. Therefore, we can say that sine, what is our B? Our B is 36 degrees over small b, we don't know, should be equal to sine C. What is our sine C? Sine C, we found it to be 92 degrees over, what is our small c? That's 7.2. Okay, so in this case, it's a matter of making B subject of the formula. So we can do cross, we can multiply both sides by sine, we can divide, anyway, let's just make subject of the formula B. For us to make subject of the formula B, B will be equal to, okay, anyway, let's cross multiply them just to make sure we are not leaving anyone behind. Okay, we'll cross multiply them, so we'll have B sine 92 is equal to 7.2 sine 36 degrees. Okay, that is cross multiplying them. That's 7. Okay, which means from there, let's go here. We have B sine 92 degrees, which should be equal to 7.2 sine 36 degrees. Okay, so we are going to divide both sides by sine 92, which means the remainder of B here will be equal to 7.2 sine 36 degrees over sine 92 degrees. Okay, so let's find that. On your calculator, sine 36 is equal to 0.587 blah blah multiplied by 7.2. See, getting to on the top is 4.23205 there over sine 92. What is sine 92 on your calculator? Sine 92 is 0.99939. Okay, so you do that. It's 4.232 divided by 0.99939. That will give you almost the same, 4.234583 centimeters. Okay, so basically that's that. That's how you do this, and that's how you decide whether to use this. Okay, that's another issue. That's another example, another simple one. I'll leave this for you to do. And there's that another one. It's another simple one. Maybe we can just do this one together. Okay, so on this one, they're saying in triangle PQR, angle Q, which is this one, is 60 degrees, and QR, where is QR? This one, QR is 9 centimeters, and PR is 8 centimeters. So here, this is what you are given. You need to know them. You are given Q, which is 60 degrees. You are given, okay, let us now label them. Remember that is Q. The opposite side of that one, the opposite side of small p, it will be small p, and there will be R. Okay, there will be R. So you have Q. In this case, that angle Q is 60 degrees. You have Q, you know is 8 centimeters. That's what you know. And you have P, which is 9 centimeters. Okay, and from this, they want you to find angle P. Okay, find P, which is that angle. Okay, so using the same thing, remember in this case we'll say sine Q over small q should be equal to sine P over small p should be equal to sine R over small r. Okay, from what you know, you will definitely understand that you don't know R, angle R, you don't even know that one, which means this one already goes out, you can't use it. In this case, you are remaining with these two. Those are the ones that you can use. Okay, so let's substitute in those two and find our P, and find our P, because it's a matter of finding angle now. Okay, so from here you will find that let's substitute sine Q. Our Q is 60 degrees over Q, small q. What is our small q? Our small q is giving us 8. This one should be equal to sine p. P we don't know. This is the one that we want to find. And over 9, which is a small p. Okay, so here it's also a matter of making a p subset of the formula. So it means you have sine p will be equal to 9 sine 6 theta over 8. So on your calculator, can you see this? Yeah. This is your calculator. Make use of that. If you don't know how to use a calculator, please show me in the comment. I may make a lesson on its own to teach you how to use a calculator. So 9 times sine 6 theta, that's 7.964, then divide by 8. This is sine p will be equal to 0.9742. Sine p will be equal to that. Let's go to the other side. Okay, it said sine p will be equal to 0.97427. 8 mabito. Okay, so for us to find p, you take sine inverse on both sides. So sine inverse on this side will remain with p. There will be sine inverse 0.974278. So if you punch on your calculator sine inverse of that, it will give you that p will be equal to 76.976 degrees, or 77, or you can just say 77 degrees. Okay, so I think